Good evening, everyone. Today, as you know, that we are going to practice some exemplar and the exercise questions as we have done our chapter, as we have completed our chapter electrochemistry. And in some days, we will going to do or practice some questions only. Like today, we are going to see the NCERT exemplars. Then we will see some CBSE PYQs. Then there will be a test for you, for all of you, for whatever you have studied till now in the chemistry, which you can attempt on our website. And then we will continue with the JEE and the NEET PYQs for this chapter. Okay. Okay, so let's start today's lecture with NCERT Chapter 2 Electrochemistry, Exemplar and Exercise Questions. Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concern or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using the generative AI, which is experimental. So this is a NCERT exemplar multiple choice question, MCQ type question, and question number 2. Okay, marked as question number 2 in the NCERT exemplar questions. The question says that electrode potential for magnesium electrode varies according to the equation this. Okay, so electrode potential means the potential of a particular electrode, and that particular electrode we are talking here is magnesium. Okay, so magnesium electrode potential varies according to the equation E of Mg positive to Mg equals to E naught of Mg2 positive to Mg minus 0.059 by 2 log 1 upon magnesium 2 positive concentration, ionic concentration of magnesium 2 positive. So the graph of E of Mg2 positive to Mg versus log of concentration of magnesium ion is. So you have to tell the graph which is correctly representing the relation between the electrode potential of magnesium electrode and the log of concentration of magnesium ions present in our electrolytic solution. Okay, so as you can see, we have 4 options given in which we have 4 graphs given. The first graph is given the graph between the electrode potential of magnesium and the log of magnesium 2 positive concentration, and the graph is a straight line and starting from x equals to 0. In the second option, we have again a graph, a similar kind of straight line graph, but there is an intercept on the y-axis, as you can see. In the third graph, we have a graph between the same electrode potential and the log of concentration of magnesium ion, but the graph is a curve. Okay, again it is also having an intercept. And in the fourth option, we have the graph where the negative slope line, or you can say negative slope straight line is given. Okay, and starting from some y equals to something. Okay, y equals to some value. So these are the 4 options. So you have to first of all, relate the question with the options given, and then you have to choose the correct option. That means the correct graph which is representing the relation between electrode potential and the log of concentration of ion. You have some time, go through it, try to solve it, and then we will continue to the correct answer. Okay, let's see. So for this given question, the correct answer is the second graph, which is the graph between the electrode potential and the log of concentration of the ion present in the ionic solution. Okay, so this is a graph which is the correct answer, and it is a straight line, have a positive slope, and also have a positive intercept on the y-axis. Now let's explain it, that how we conclude this graph as an answer of this question. So electrode potential for the magnesium electrode, as we are talking about the electrode potential and magnesium electrode, the electrode potential for the magnesium electrode will vary according to the equation, this Nernst equation which is already given in the question. E equals to E naught minus 0.059 by 2 log 1 upon magnesium 2 positive. It is already given in the question, and it is already said that electrode potential, that means E of the magnesium electrode, vary according to this given equation. Now we just have to solve this or simplify this. So log of this, okay, so we have log of 1 upon x. Let's say x is the concentration of the magnesium ion. Okay, we can write it as log of x to the power minus 1, right? That's a fraction property, that if somewhere it is written as 1 by x, you can write it as x to the power minus 1, right? What does it mean? That it is equals to, somewhere if x to the power minus 1 is given, you can write it as 1 by x, right? So simply we are doing this here. So it will become log of x to the power minus 1. Now this is a log property. Log is in the base 10. Okay, there is another logarithm which is ln, in the form of ln, whose base is e. Okay, so here in the log 10 x to the power minus 1, this is a property of the log. Remember that log of m to the power n equals to n log m. Okay, so this is a property which we are using here by just a simple simplification. Firstly, we have written the 1 upon magnesium 2 positive as magnesium 2 positive to the power minus 1. Okay, so we have write it as magnesium 2 positive to the power minus 1. Okay, this concentration is in minus 1 power. Now this minus 1, using this log property, log of m to the power n is equals to n times log m. That means whatever is present in this power, okay, whatever is present in the power of the log, that will come in the product form. Okay, so this n will come here in the product with the log of m. So here the power is minus 1, so minus 1 will come here, okay, in the multiplication form. But this term is also in the multiplication with the log term. So let's say that you take the minus 1 here and multiply by the already present minus, and minus will become plus. Okay, that's why we have written it as positive 0.059 by 2 log of magnesium 2 plus. Okay, so we just have written this like this. Okay, so this is the simple simplification. We just have simplified this this equation already given in the question. We use the log property and put the minus 1 in the power to the product form. Okay, and minus will become plus, so that's why we are writing here as a plus. So E equals to E naught of plus of 0.059 by 2 log of magnesium 2 positive. Now you can also write it as 0.059 by 2 log of magnesium 2 positive plus E naught of magnesium 2 positive by mg. So we just have done the rearrangement, like we have written this at this place and this at this place, nothing changed. Okay, so we just have write this equation as this equation. Now why we are doing this? So basically, let's see that why we are doing this. We just want to, as you know, that we have to identify the graph, right? In the graph, there is a curve, there is a straight line. So we just relate the given equation, or after the simplification, the equation we get, we just relate this with the equation of the line or either a curve. Okay, so to identify that which option represent the correct graph between the electrode potential and the log of concentration of the ion. So let's see. Now this equation we just derived represents the equation of straight line. It can be correlated. How can you correlate? So E equals to 0.059 by 2 log of magnesium 2 positive plus E naught of magnesium 2 positive plus magnesium 2 positive to Mg. This was the equation we have derived, right? Now the straight line equation is Y equals to mx plus C. This is the most basic and the first equation of the straight line which we studied in the mathematics, right? In the straight line chapter. So Y equals to mx plus C. Y represents the coordinates of the y-axis. X represents the values or coordinates at the x-axis. M represents the slope of the line. Okay, and C represents the intercept of the line. Okay, so this is why, because we have to make the graph between the electrode potential versus the log of magnesium 2 positive. That means this is our y and this is our x. So we have arranged the equation such like that this value will become our y in the equation and this value will become as x in our equation. So if you see, y equals to this quantity is a slope, so m log of mg 2 positive, this is x, right? So this is x plus this is intercept. Whatever is left other than the y value, x value and the slope, that is intercept. So this is equation y equals to mx plus c, right? So m is this quantity 0.059 by 2. If you remember that this was initially in the negative, but we made it in the positive by doing this 1 by x to the power minus 1, right? So this slope finally we are having in positive, right? And intercept is also positive of E naught magnesium 2 positive to magnesium. So intercept, that is C, is equals to E naught of magnesium 2 positive to magnesium, which is positive value, and equation can be diagrammatically represented as, so if you make the diagram for the equation which we have get this, that will be this one, that at the y-axis we should already take this electrode potential. At the x-axis we should take this log of concentration of ion, and now the remaining is intercept, which is positive. So at the positive y-axis we are getting some intercept which is E naught of the electrode of magnesium, and the slope is positive. That means our straight line will be like this structure. Okay, if the slope will be negative, then this will be the structure of the line in this direction. Okay, so that's why we have the correct answer as the slope which is present in our second option. Okay, as this diagram. Okay, so let's see the next question. This is also a NCERT Exemplar multiple choice question, and this is marked as question number 16 in the NCERT Exemplar. The question is that lambda naught m of NH4OH is equal to, okay, if you remember, we have studied in the theory part about Kohlrausch law, right, where we have studied about the molar conductivity of different ions, right? So we just have to apply that or use that here or keep in mind while solving this question. So we have given that lambda naught of NH4OH, this compound, is equal to what? So how will you derive this, and how will you mark the correct option as the answer? So options given are lambda naught m of NH4OH plus lambda naught m of NH4Cl minus lambda naught of HCl, or lambda naught m of NH4Cl plus lambda naught m of NaOH minus lambda naught of NaCl, or lambda naught m of NH4Cl plus lambda naught m of NaCl minus lambda naught of NaOH, or lambda naught m of NaOH plus lambda naught m of NaCl minus lambda naught of NH4Cl. So you have to identify that which equation in the option representing the correct lambda naught m of NH4OH value. Okay, so you have some time, go through it, and then we will continue to the correct answer. Try to solve this. Okay, Okay, now let's see. So for this given question, the correct answer is the second one, which is lambda naught m of NH4Cl plus lambda naught m of NaOH minus lambda naught of NaCl. Okay, now let's see how. Let's see how we can explain it or write it. So lambda naught of NH4Cl. First of all, we have this answer in which NH4Cl, NaOH and NaCl is present. Now, initially we don't know the answer, right? But we know that what are the compounds in which are already present in our options. Okay, that means what are the compounds which we have to take, which we have to consider for solving this question, right? So let's write the equation for lambda naught m of NH4Cl, which is also given as a compound in our options, right? So lambda naught m of NH4Cl is lambda naught m of NH4 positive plus lambda naught m of Cl negative. Here 1 is also in multiplication, because if you remember, lambda naught m according to the Kohlrausch law is nu positive to lambda naught positive plus nu negative multiplied by lambda naught negative, right? That means the number of ions, or you can say the number of positive ion multiplied by the molar conductivity of the cation plus number of negative ion multiplied by the molar conductivity of the anion, right? So similarly, we have written this equation because NH4Cl, we have NH4Cl. So NH4Cl will dissociate into NH4 positive plus Cl negative, right? That means positive ion is 1 and Cl negative, that is anion, is also 1. So there is 1 in the multiplication with lambda naught m. Let's say this is the equation 1. Now we solve for the another compounds. So lambda naught m of NaOH will be lambda naught m of Na positive plus lambda naught m of OH negative. Here also the 1 is already in the multiplication, because as I said that you have to remember the new term, so which will be the number of ions. Now if NaOH will dissociate, it will dissociate into Na positive plus OH negative, right? That means 1 cation we got and 1 anion we got. So number of ions are 1 and 1. So 1 is in the multiplication in this term, and lambda naught equals to lambda naught m of the cation Na positive plus lambda naught of OH negative, the anion. And let's suppose this is second equation. Now we write the similar equation for another compound. So lambda naught m of NaCl, which is the third compound in our options, will be equals to lambda naught m of Na positive plus lambda naught m of Cl negative. NaCl is similar like of NaOH. NaCl will dissociate as Na positive and Cl negative, right? 1 is cation and 1 is anion. So here also 1 is in the multiplication, but we haven't write it. We haven't shown it because it is not necessary. 1 into something will be that something. So let's suppose this is third equation. Now when you apply first plus second minus third, okay, so when you add these two, why we are adding these two? Because we have to find out the lambda naught m of NH4OH. If you dissociate the NH4OH, it will dissociate into NH4 positive plus OH negative, right? So lambda naught m of NH4OH will be lambda naught m of NH4 positive plus lambda naught m of OH negative. So you have to conclude at this equation finally after all the addition or subtraction of the equations first, second and third. So if you see, we have NH4Cl and NaOH. We want OH and the NH4 term in the addition. So NH4 will add with OH if you add the first and the second equation, right? So we are adding first and second equation. Now the extra products are in the first and second equation addition. The extra are chlorine and sodium, okay, and both are present in our third equation. So we subtract the third equation, right? So that's why we are writing here that apply first plus second and subtract the third equation. When you do this, it will become lambda naught of NH4Cl. So left hand side will subtract first, then right hand subtract will subtract among themselves. So lambda naught of NH4Cl plus lambda naught of NaOH minus lambda naught of NaCl equals to lambda naught m of NH4 positive plus lambda naught m of OH negative, because rest will cancel out. Na positive will cancel out because one is in positive, one is in negative, and Cl negative will also cancel out as one is in positive and another is in negative sign. Okay, and this which we get after this one first plus second minus third equation, we get this which is equals to lambda naught m of NH4OH. Hence, we have the correct answer as option 2. Okay, so this is the correct answer, which is option 2 for this question. Okay, let's move on to our next question. Okay, now this is an NCERT example, a multiple choice question, which can have more than one options as correct answer. And this is marked as question number 20 in our NCERT example. The question is that E naught of cell is equals to 1.1 volt for the Daniell cell. Daniell cell was the very first cell we have studied in this chapter, okay, where the zinc and the copper are present, right, as the electrode and as the electrodes, right? One is cathode, another is anode. So the E naught, the standard cell potential for that is 1.1 volt, right? So which of the following expressions are the correct description of state of equilibrium in this cell? Now we have given some values or the expressions in the options. You have to tell that which expression are correct description of state of equilibrium in this cell. Okay, so the 4 options given are that first of all you have to identify the correct answer, the correct option, which are representing the equilibrium state which established in the Daniell cell. Okay, so when the establishment of the equilibrium will happen in the Daniell cell, what is the equation you will get, that you have to identify. So options are Kc equals to 1.1 volt. Kc is the reaction constant or equilibrium constant, or 2.303 RT by 2F log of Kc equals to 1.1, or log of Kc equals to 2.2 divided by 0.059, or log of Kc equals to 1.1. So you have to select the one option among them. You have some time, try to solve it, try to explore it, analyze it, and then we will see that how can you calculate and what will be the answer. Okay, let's see. So for this question, the correct answer is our second option and the third option. Okay, that means 2.303 RT by 2F log of Kc equals to 1.1. This is the expression which is applicable at the equilibrium in the Daniell cell. And also the third equation is also correct, which is log of Kc equals to 2.2 divided by 0.059. Okay, so let's see that how it is the correct answer. At the state of the equilibrium, when equilibrium arrived, the del G will become equals to minus of RT ln Kc. This is the equation for the Gibbs free energy we use, which is del G naught equals to minus of RT ln Kc, where R is representing a constant, T is representing a temperature, and ln of Kc is ln of the equilibrium constant. Now del G naught is also equals to minus NF E naught, right? This is also, so these are some small you can say formulas that you have to learn, okay, for the proper solving of the numericals from this chapter. Okay, so the first equation we have seen is that del G naught is defined as minus RT ln Kc. Okay, and del G naught is also equals to minus of NF E naught. Okay, so we have these two equations for the del G, so we relate them with each other. So we write minus of NF E naught equals to minus of RT 2.303 log Kc. So we convert this ln to the log term, log base 10 term, by just multiplying it by 2.303. This is also a log property. Okay. Now E naught equals to RT of, because this minus will cancel out, right? And whatever the term we have common, that will also cancel out. So after that, the E naught will be equals to RT, that is this, multiply by 2.303 log of Kc, and this N times F will come in the denominator, and for the Daniell cell N equals to 2. Okay, because 2 number of electrons were contributing in the redox reaction which is happening in the Daniell cell. Okay, so this is the equation for the E naught we just derived at the equilibrium, remember. Okay, so first of all we relate this or try to convert this into the equation which are given already in our options to match the correct answer, to conclude the correct answer. So since at equilibrium the E naught is already given as 1.1 volt, right? The E naught is given as 1.1 volt for the Daniell cell as at the equilibrium. So we put this value in the equation, that which is E naught equals to this much, right? So therefore 2.303 RT by 2F log of Kc equals to 1.1 volt, right? And log of Kc, if you write it, it is the second option. Okay, and if you write the log of Kc value, it will be 2F will go here in the multiplication, so it will become 2.2 divided by, okay, so you can derive this as log of Kc equals to 1.1 multiplied by 2F divided by 2.303 RT. Now if you have remember in the Kohlrausch law, or while solving the Nernst equation, not the Kohlrausch law but the Nernst equation, I taught you that this this F is a constant, which is Faraday's constant, R is a constant, T is also the temperature which is already given, or you consider the 298, that means the room temperature, and 2.303 is also an integer, fixed integer. Okay, so you can solve these values, right? And when you solve these value, they will come as equals to 0.059. Here, as Faraday is already in the numerator, in there this denominator term, that means 0.059 is equals to 2.303 RT by F. This fraction has the value of 0.059 after putting all the constant values at their place, and then after solving this fraction. Okay, but here this equation is inversed. Okay, Faraday is in numerator and this term is in denominator, so this 0.059 is also inverse, so it will become 0.059, right? And similarly we write it as, so 2 times 1.1 will become 2.2 and 0.059 will go in the denominator, okay, on solving. Okay, so these are the two options, that is the second one and the third one, which are representing the equilibrium state condition or the expression. Hence, the option second and the third are the correct choices or the correct answer for this given question. Okay. So, let's see the next question. Okay. So, this question is NCERT Exemplar short answer type question, which is marked as question number 34 in our NCERT Exemplar. The question says that value of the standard electrode potential for the oxidation of the chloride ions is more positive than that of water. Even then, in the electrolysis of aqueous sodium chloride, why is chloride ion oxidized at anode instead of water? Okay, try to understand that what is our question is asking. Okay, this is a short answer type question, so you have to explain it in some para or 4 lines or 2 or 3 lines. So, the value of the standard electrode potential, which is E naught of the cell. So we are talking about the E naught of the cell. So E naught of cell value for oxidation of chloride ion. Oxidation happens by, oxidation happen by this, that chlorine negative will go into chlorine and electron. Okay, so the electrode cell potential, standard electrode potential, or the value of the E naught of the cell for oxidation of chloride ions is more positive than that of water. Now water has some electrode potential, and this process also had some electrode potential. We are saying that E naught of the Cl negative cell is more positive, more positive than the water reaction or the water electrode potential. Even then, in the electrolysis of aqueous sodium chloride is NaCl in the aqueous form. When you do the electrolysis of this sodium chloride in the aqueous form, why is chloride oxidized at the anode instead of water? So why the chlorine which you get from this, Na positive and chlorine negative, so the chloride ion, why they are oxidized at anode? At the anode, what happens? At anode, we do the oxidation process. The electrodes are divided into the anode and the cathode, and the process which happens on the anode is oxidation, and chlorine will go on the anode to do the oxidation process. So we are asking, if the E naught potential of the chlorine negative is more positive than the water, then why it is going to the anode, the chlorine ion is going to the anode and performing the oxidation process in the electrolysis of sodium chloride. Okay, so let's see. So first of all, try to understand the question. In the examination, students do this mistake that they don't try to understand the question, and they just, in the first read, in the first go, whatever they will understand from the question, they start writing. But this is the main problem in the measure of the cases with the students. So try to understand the question and try to analyze in your mind only that how can you answer it, how you start, how you will end this the answer for this question. Okay, so analyze it, then we will see the correct answer. Okay, let's see. So for this given question, we have to first of all write the condition that under the condition of electrolysis of aqueous sodium chloride, the oxidation of water at the anode requires overpotential. Okay, now when you do the electrolysis process of aqueous sodium chloride, then if the oxidation of water will happen, it will need a over potential. That means you have to provide extra potential to perform the oxidation of water at the anode. So chloride ion is oxidized at anode instead of the water molecule, and possible oxidation half cell reactions occurring at the anode are in the electrolysis of sodium chloride. Okay, so we are talking about in the electrolysis process of the aqueous sodium chloride, the half cell reaction or possible oxidation half cell reaction which can occur at the anode, that are, first is this one for the chlorine, which is chloride ion converts to half of Cl2 plus electron, and the electrode cell potential, standard cell electrode potential for this is 1.36 volt, which is positive. And the another possible oxidation half cell reaction which can occur at anode is for the water molecule, which is 2 of water molecules. It will undergo to the conversion of oxygen, 4 protons and 4 electrons. Both are oxidation process, and both can be possible to occur at the anode. This is also has the E naught, that is standard electrode potential value, as positive, which is 1.23 volt. But if you compare these two, this is greater, this is smaller. Chloride ions electrode potential value, standard electrode potential value is greater, and the water standard electrode potential is lower, a slight lower. Species which having lower E0 of cell undergo oxidation first, then the higher value. Okay, now the concept says that the species which are having the E0 value lower will undergo the oxidation first, and then the higher value of E0 will go under oxidation. But here the oxidation of H2O, that is this process, the oxidation of H2O to the oxygen gas is kinetically so slow that it needed some over voltage. This process is very slow that you have to provide extra voltage to it. That means you can consider this E0 as double. Okay, because one process gone, E0 is this. Then again you have to provide the extra potential. Then this process will complete. Okay, for the oxidation of water molecule to the oxygen gas. This conversion, you need over potential. That's why in the case of the electrolysis of the aqueous sodium chloride, we consider the oxidation of the chloride ion at the anode rather than the water molecule oxidation at anode. This was the reason. Okay, so this is like how you can answer this short type answer or short type question. Okay, you just have to focus on the major things which is already present as a hint in our question. Like we have already given that value of standard electrode potentials. So first of all, you have to write the values to prove your answer in your answer. Okay, the values of standard electrode potential. So we are using the values of E0. Okay, then it is given that the chloride ions have standard electrode potential more positive than that of water. Then you have to show that how that they are relating, why we are saying that, and why we are focusing on this concept that it is more positive than this. Okay, even then the electrolysis of aqueous sodium chloride, then we consider this case that which is on which the question is that in the aqueous sodium chloride the electrolysis happens and the chlorine will go the oxidation process at anode. Now you have to describe relating this E0 values of the possible reaction that can happen at the anode. Then you can answer this question properly by relating these. Okay, so this is the correct way. Okay, so let's move on to our next question. This is again a NCERT Exemplar short answer type question, which is marked as question number 39. The question is, how will the pH of brine? Brine is a name of aqueous sodium chloride solution. Remember, this is important, okay? Because if in the examination somewhere is written as brine, you consider it as aqueous sodium chloride solution. Okay, so how will the pH of the brine be affected when it is electrolyzed? So when you perform the electrolytic or the electrolysis process in the brine solution, then how the pH of that brine solution be affected? Okay, so that you have to answer. It is a short answer type question, so 3 to 4 lines. You have some time, try to solve it in your mind or maybe on the paper, and then we will continue to the correct answer. Okay, let's see. So for this given question, we will solve it as that the pH of the solution will rise. That means it will increase. Yeah, it will increase. Why? As the sodium hydroxide is formed in the electrolytic solution. When you do the electrolysis process in the brine solution, the product you will form is sodium hydroxide, and due to that the pH of the solution will increase. Okay, why we are saying that? Now you have to focus on the acid and base concept. Sodium hydroxide is a base. Sodium hydroxide is a base. Sodium chloride, which was the initial solution, NaCl. NaCl is a salt. It is a salt. It is made up of acid and base combination by the neutralization reaction between the acid and the base. Okay, Then we got NaCl. Now, if you are doing the NaCl solution electrolysis, then the product that you will get is sodium hydroxide, which is a base due to the presence of the OH negative ions, hydroxyl ions in this compound. Okay, and as you know that the pH of the acids are belonging to the less than 7 range. Okay, so pH is less than 7 for the acids and pH is greater than 7 for the bases, right? And 7 pH is considered as the neutral pH if you look at the pH scale. Okay, so if we are getting a product as base after the process, after the electrolysis process which we are doing in the brine solution, so the pH of the solution will increase. It will go from acidic or neutral to the basic side, so that will increase. Chemical reactions which are occurring at the cell when the aqueous brine solution is electrolyzed are as follows. So the chemical reaction happening during the electrolysis processes: sodium chloride in the water converting to sodium positive plus chlorine negative. They are dissociating into their respective ions. And at the cathode, the reaction happening is the reduction of the water molecule. So one electron is adding into the water molecule and it will dissociate into the H2 molecule and the hydroxyl ions. Okay, and at the anode, the reaction happening is the chloride ion oxidation, which is chloride ions oxidized to half of Cl2 plus electron. Okay, we have just studied this in the previous question also, right? So chloride ion converting to half of Cl2 plus electron at the anode. The overall cell reaction, the net reaction will be the sum of these two reactions. And this reaction, because it is the electrolyte which is present in our solution, so the overall net reaction will be NaCl. This NaCl will add up with the water molecule, and this chlorine negative is present at the left hand side, and this is present at the right hand side. This will cancel out, and after the arrow, after the addition of NaCl in water molecule, we will get sodium positive here, OH negative here, half of H2 here, and half of chlorine gas molecule. Okay, so this is the net reaction which is happening, right? And we are getting hydroxyl ions in our reaction, in our net reaction. So these two will combine together because they have tendency to combine and they will form NaOH, as this is a base. And if in a solution the OH negative ions are present, that means the solution is basic. Okay, so the pH from the salt of the pH of the salt to the pH of the base, so the pH will increase. Okay, let's move on to the next question. This is a NCERT Exemplar short answer type question and it is marked as question number 46. So question is that write the Nernst equation for the cell reaction in the Daniell cell. Remember, I said that this is the first type of cell which we have studied in this chapter. So you have to write the Nernst equation. We have also studied about the Nernst equation. So you have to write the Nernst equation for the cell reaction happening in the Daniell cell, and how will the cell potential be affected when the concentration of zinc 2 positive ions is increased in the Daniell cell. Okay, if you increase the zinc 2 positive ions, then how the overall cell potential will change or affect, that you also have to tell. Okay, so try to solve it and analyze it, then we can continue to the correct answer. Okay, let's see. So for this given question, so this is a cell representation. This is cell representation for the Daniell cell, which we have seen already. So zinc to zinc 2 positive, salt bridge, copper 2 positive to copper. One is representing the anode, another one is representing the cathode. So at anode, the reaction which is happening is that zinc is undergoing the oxidation process by releasing 2 electrons, and zinc is converting from neutral to the 2 positive charge, positive ion. Similarly, at the cathode, reduction process happens, which is for the copper. So copper 2 plus will gain 2 electrons and become copper in the neutral form. So plus 2 will go to the 0, that is neutral form. These are the respective reactions happening at the anode and the cathode. Overall cell reaction will be the sum of these two, which is zinc plus copper 2 plus will give you zinc 2 plus plus copper. This two electrons and 2 electrons will cancel out as they are present at left hand side and the right hand side of the reaction arrow. So this will be the overall cell reaction. Okay, now you have to write the Nernst equation for this cell reaction in the Daniell cell. So this is the Daniell cell overall cell reaction. You have to write the Nernst equation for this. If you remember, the Nernst equation involves the E naught of the cell, that means the standard cell potential, and the E of cell, that is potential of the cell. Okay, and the concentration of the product and the reactant of ions. Okay, so this you can write it as Nernst equation E of cell equals to E naught of cell minus 0.0591 by 2 log of zinc 2 positive in the product side divided by copper 2 positive in the reactant side. Okay, copper and zinc here are in solid form, that's why we are not considering them here in the product and the reactant in the numerator and the denominator respectively. Okay, but copper 2 plus and zinc 2 plus are in aqueous form, so that's why we are considering it here. Only the aqueous or the gaseous form product or the reactant will be considered here in the log term. So this is the representation of the Nernst equation. If you remember 0.059, I explained that 0.091 is the value of 2.303 RT by F. Okay, in the Nernst equation, with this term n here also comes, so we are taking n equals to 2 already here, and this value, okay, we can write it here. This value is 0.0591, so we solve it and write it as 0.0591 by 2 log of the product divided by the reactant. Now you can also write it as E of cell equals to E naught of cell plus 0.0591 by 2 log of copper 2 positive by zinc 2 positive. What we have done? We reversed these. So we are here as log of zinc by copper 2 plus 2 plus. Okay, let's suppose this is log of x by y. X is zinc and copper is y. Now if I write it as log of y by x, the value will change, right? So what we have done, we just did this. We take log of x will go in the denominator and y will go in the numerator if you take the whole power as minus 1, right? So y by x to the power minus 1 will be equals to x by y. This is the property which we are using here. Y by x to the power minus 1 equals to x by y. Okay, this whole power minus 1 means y to the power minus 1 divided by x to the power minus 1. That means 1 by x to the power minus 1 means it is x. Right, if you take this x to the power minus 1 in the numerator, the negative power will become positive power. So it is equals to x, and y inverse equals to 1 upon y. Right, so we are representing y by x to the whole power minus 1 equals to x by y. Okay, so we just rearrange this zinc to the denominator and this copper ion to the numerator, and the minus 1 which go in the power, we use the logarithmic property here and take this minus 1 in the product with the log. So this minus 1 and this minus 1 already present, multiplied and become positive, minus minus plus. So this here it will be plus. That means there are two ways we can write this equation, that is Nernst equation, which is first is this one and second is this one. Now according to these equations, E of cell is directly dependent on the concentration of the copper 2 plus and inversely dependent upon the concentration of zinc 2 plus. Now as the positive term has come, that means E of cell is something, E naught plus something, some value, right? Because concentration has some values for the ions, right? Then if you apply the log, that will also come in some integer form or in the numerical form. Okay, so E of cell is basically E naught of cell plus some term, numerical term, right? Which is representing that E of cell, this is directly dependent on the concentration of the copper 2 positive, which is present in the numerator. So this E of cell is directly dependent upon this value of the concentration of copper ions and inversely dependent upon the value of concentration of zinc 2 plus ion, because it is present in the denominator. If in the log the denominator will increase, okay, this log value will also, you can say, decrease, right? And here this E cell value will also decrease, right? But if the copper 2 plus ions value will decrease, the E cell value will decrease. So basically directly proportional means E of cell is directly proportional to the concentration of the copper 2 plus ions. That means that means if this increases, this also increases, and E of cell is inversely proportional to the zinc 2 plus ions. That means if this increases, this will decrease. Okay, so if the zinc 2 plus ion concentration increase here, the E cell value will decrease, and if copper 2 plus ion concentration will increase, the E cell will also increase. This is the basic concept which we are going to use here, because we have to also answer the question that how the E of cell, the potential of the cell, is affected when the concentration of zinc plus ions, 2 plus ions, is increased. So as I said, zinc 2 plus ion concentration is inversely related to the potential of the cell. Then how they will affect? E of cell will decrease when the concentration of zinc 2 positive ion increased. Okay, because they are inversely related, inversely proportional. One will increase, then another will decrease. Okay, so this is the relation. This is how the E of cell, the potential of the cell of the potential, potential of cell will affect when you increase or decrease the concentration of zinc 2 positive ions in this Daniell cell, which is having this cell reaction. Okay, so this is the Nernst equation for the Daniell cell, and we just derive this Nernst equation as this one and conclude that how the potential of the cell will affect. Okay, moving on to the next question. This is a NCERT Exemplar short answer type question marked as question number 47. What advantage do the fuel cell have over the primary and the secondary batteries? Okay, batteries and the fuel cells we have covered in the last 2 lectures. So you have to tell that what are the advantages of using fuel cell other than the using primary or secondary batteries in our chemical processes. So you have some time, think about it, then we will see what is the correct way of answering this question and what will be the answer. Let's see. So for this question, the primary batteries, first of all, we have to understand the fuel cell, primary batteries and secondary batteries. Primary batteries contain a limited amount of reactant and they are discharged when reactants have been completely consumed, completely utilized. That means when the reaction of this conversion of chemical energy to the electrical energy will completed by the overall consumption of the amount of reactants which is already limited present in our primary batteries, then the primary batteries get discharged and we have to throw it away. The secondary batteries, meanwhile, can be recharged, but it will take a longer time, right? So in the secondary batteries, once the reaction of the conversion of chemical energy to the electrical energy, once this reaction of this conversion process will complete and the battery get discharged, you can recharge it again in the secondary batteries. But this recharging and charging process is limited, and the recharging process will also take a long time. Fuel cell, on the other hand, run continuously as long as the reactants are supplied to it and products are removed continuously. Okay, because if you remember, we have seen the structure of the fuel cell, right, which is used in many ways and in various applications. It has various applications in the astronomy, also in the spaceships, right, for the water, for the drinking water, right, for the electrical power energy in the spaceships and all, right? So fuel cell is really have advantage because it will run continuously as long as you will provide the reactants. If you remember, it has something this kind of structure. These are the openings I am making. Okay, these are the openings, and through these openings you can provide the hydrogen and oxygen as reactants, and through this opening you can get the product, and you can provide the reactant as long as you want, okay, for the functioning of the fuel cell. Okay, so unlike primary and the secondary batteries, the fuel cell we can provide to the fuel cell as much amount of reactant as we want and as long as we want for the functioning of the fuel cell and for getting the products. Okay, and you can say for removing the products continuously, because as long as you are providing the reactants, you can get the product and you can remove it from here, and then again you can add the more reactant for this fuel cell in this fuel cell. Okay, so that is why these are the advantage over the primary and the secondary batteries. So these are the advantage of fuel cells, using the fuel cells. You can add some more points according to yourself, whatever you have been remember at that time while writing the answer, right? The comparison basically between the primary secondary batteries and the fuel cells for showing that there is a advantage of using fuel cells. Okay, so that's all for today's session. Thank you so much.